So let's look at our first curve sketching example. I want us to analyze and sketch the graph of the function f of x, which is 2x squared minus 9 over x squared minus 4. So we're going to start with remember our guidelines. The first thing you want to do is you want to find the domain of this function. So here I have a rational function, so if I set the denominator equal to 0 and solve, you're going to get x equals plus or minus 2. So that's the only values that x can't be. So the domain would be negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. So there's my domain. Now we're going to find our x-intercepts. So you're going to set y equal to 0. Well, that's the same thing as setting the numerator equal to 0. Divide by 2, and I get two solutions. I get x equals 3 and negative 3. So my two x-intercepts are negative 3, 0, and 3, 0. Now let's look for our y-intercept. We're going to plug in x equals 0 into our function. So if I plug in x equals 0 into my function, I'll get positive, if I simplify that, I should get positive 9/2. So my y-intercept is the point 0, 9/2. So I've got all my intercepts now. Let's find our asymptotes. We have, we'll start with our vertical asymptotes. We have two of them. X equals negative 2 and x equals 2. Next, we're going to find our horizontal asymptotes. So if I take the limit as x goes to infinity of my function, 2 x squared minus 9 over x squared minus 4, the degrees are the same in the numerator and denominator, so the limit will be the ratio of the coefficients. It's 2. The same thing if you take the limit as x goes to negative infinity. It's a rational function. The numerator and denominator have the same degree, so the limit would be the ratio of the coefficients. It's 2. So my only horizontal asymptote is y equals 2. So now we're going to take our function and find the derivative. So remember, our function is 2x squared minus 9 over x squared minus 4. And you're going to have to use the quotient rule to find your derivative. It'll be low. The derivative of the top will be 4x minus the top. I'm just going to go ahead and distribute that 2. The derivative of the bottom is 2x over x squared minus 4 squared. And then what you need to do is you need to simplify the numerator. If you do that, you'll get 20x over x squared minus 4 squared. So if I look for where is this undefined, it's undefined when x equals 2 or negative 2, but my function is undefined there, so I don't get any critical numbers except for when is it equal to 0. Well, that's when 20x equals 0 and x equals 0. So this is my only critical number. So now I need the second derivative. You're going to have to use the quotient rule again. Find the second derivative. The bottom times the derivative of the top, which is 20, minus the top, the derivative of the bottom, using the chain rule. It's 2 x squared minus 4 times 2x over x squared minus 4 squared. And now you're going to simplify, squared, so it should say to the 4th power here. Now you're going to simplify the numerator. You can cancel out an x squared minus 4 everywhere. So I'm going to take 1 away from all my terms here. X squared minus 4 cubed. And if I simplify the numerator now, you're going to get negative 20 times 3x squared plus 4 over x squared minus 4 cubed. So I want to know, where is this undefined? Again, you look at the denominator, 2 and negative 2, but my function is undefined there. And then the only place, so what's left is looking at, when is it equal to 0? So that's when the numerator is 0. This has no solution to it because the smallest this left-hand side could be is 4. So there's no way it could equal 0. So I'm getting that there are no inflection points here. And so now I'm going to make my sign charts for my first derivative. And then I'll make the second derivative also here. So I'm going to put my critical number on here. I'm also going to mark where my function was undefined at negative 2 and 2. So we need to pick some test numbers. I'll pick negative 3, negative 1, 1, 3. And you're going to go back to your first derivative. So go back here and see if it's positive or negative. Now notice this bottom, it's a square, so it'll always be positive. So you just need to look at the top, 20x, for the sign. Is it going to be positive or negative? So if I take 20 times negative 3, that would be negative. 20 times negative 1, negative. 20 times positive 1, positive, and a positive. So remember that your function is undefined here at negative 2 and 2. Okay, and then here my function, if it's negative, it's decreasing, decreasing, increasing, increasing. Now here my function switches from decreasing to increasing, so that means I have a relative minimum there. Here's I have a relative minimum. Now go to your second derivative and plug in your same test points. Plug in negative 3, negative 1, 1, and 3 into here. Now notice that your numerator will always be negative. So really your sign is just coming from the denominator. If I plug in negative 3, the denominator would be positive. Right, so what I'm doing is I'm plugging in into my second derivative, plug in -3. Over 9 minus 4 cubed. So this would be a negative over positive. This will be negative. And you repeat that for your other test values. So it'd be positive, positive, and negative. So remember what these mean. So my function's undefined at these locations. Negative means concave down. Positive means concave up, and then concave down. So now that we have all this information, we can actually get a really good picture of what the graph looks like. So I'm going to go down here and we're going to sketch this graph. Okay, so remember I'm going to start with my asymptotes. I have an asymptote at x equals -2. I have an asymptote at x equals +2. And I have a horizontal asymptote at y equals 2. And then I'm going to plot my x-intercepts and my y-intercepts. So I had -3, 0, +3, 0, and then it was 9 halves. It was 0, 9 halves. 4, 5. So let's see. I need to go up a little bit higher here. 3, 4, here's 5. Here we go. Okay, and now we're going to refer to our sign chart to help us fill this out. So to the left of -3, so if I look over here, my function is decreasing and concave down. So my function should be decreasing and concave down. And it's going to go towards my horizontal asymptote there, so decreasing and concave down, and all the way down here. Okay, and then from -2 to 0, my graph is decreasing and concave up. So if it's decreasing and concave up here, it'll be going down. Okay, and then on the other side of 0, it's going to be increasing and concave up, increasing and concave up. And then on the other side of my vertical asymptote, it's going to be increasing and concave down. So it's always going to be increasing, so it should be going upwards, and concave downward the whole time. So there, if I kind of zoom out a little bit, there is the sketch of my graph right there.